This conference will now be recorded.
Good afternoon, one and all. To all the dear participants, it's my privilege to welcome you all for this 5-day faculty development program on research trends in thermal engineering 2020. I request all your participants to kindly mute your audio and video so that the session can be run uninterruptedly. I take my privilege in introducing myself, institution, and the Department of Mechanical Engineering. Myself, Pawan Vikas, Assistant Professor, Department of Mechanical Engineering, BITM, Bellary. BITM is one of the pioneer institution in the Gulbarga region of VTU, and it has got state-of-art facilities located in Hospet Bellary Highway. The institution is one of the institutions of Basrajeshwari Group, headed by Director Yashwat Bhupal and the Deputy Director Prithviraj Bhupal and the Principal Dr. V.C. Paji, Vice Principal and Head of the Department of Mechanical Engineering, Dr. Edvalli Baswaraj, and the BITM college is recognized by NAC and NBA, which is established in the year 1997. The department was established in the year 1997 with an intake of 60, and presently it is run by with an intake of 180, and the BITM is recognized as one of the research center with 30 plus staff and 8 PhD faculties who are indulged in the college institution development and also along with the research areas in various regions. And I also, as a part of this, the PPT is being organized for the knowledge sharing purpose. And once again, I welcome you all the participants for this session. Now, I request Dr. Raghavendra Joshi sir to introduce our speaker, Dr. Navidigi. Over to you, sir.
So, good afternoon to all the participants. I welcome for the first day of the faculty development program on research trends in thermal engineering. And myself is Dr. Raghavendra Joshi, so professor in the Department of Mechanical Engineering. It is my immense pleasure to introduce the today's speaker is Dr. Mallinath C. Navindigi. Presently, sir is working as a professor in the Department of Mechanical Engineering, PDA College of Engineering, Kalaburgi. So, sir is completed engineering in the year 1986 from Gulbarga University, Gulbarga, and later pursued masters in automobile engineering from Bombay University, Bombay in the year 1991, and completed his postdoctoral program, pursued his PhD from JNTU Hyderabad and in the year 2015. So presently, sir is a professor in the Department of Mechanical Engineering under professor. So currently, the 5 candidates are pursuing the research, and already the 2 have been awarded a PhD degree. And in addition to that, our speaker has contributed innovations with respect to the teaching learning activities, and also he has contributed in establishing the various laboratories, and also he is having an institutional membership of ISTE and the MIE. And in apart from this, sir has been delivered the invited talks as a resource person in many of the institutions, and also sir is the reviewer for one of the international journal, has reviewed so many articles, and personally, so he has published around about 55 publications, and also presented a paper in 9 national and international conferences. So with this, sir is having one more peculiar characteristic. So I saw him. So handwriting is simply a superb. It is looking like a print. So it is like a whatever we print with our systems, same thing manually sir is going to write. His handwriting is like that. is peculiar. Navindiki sir means handwriting is like a printing. So with this brief introduction, now I will hand over to the today's speaker, Professor Sir Navindiki sir. Now you can continue, sir. Now you can continue, sir.
Okay.
Yes.
Thank you, Jose sir, for the brief introduction and kind words about me. And good afternoon, all the participants for this faculty development program on research trends in thermal engineering, organized by BITM, Bellary. So today in this session, so I'll be engaging or I'll be talking on the recent trends that are taking place in IC engines. So before talking on this IC engine, this one recent advances. So you being the thermal power stream participants, so I think you are well aware of IC engines and you have studied much more about these fundamentals. Okay. Now here in this session we'll be discussing about the recent advancement that are taking place on this field. Basically, why the advancements or the improvements or modifications are needed for the IC engines? That's the main questions, the problem before us. The IC engines, okay, so it's, as you know, so it's a heat engine which converts the heat energy into the mechanical energy efficiently out of the other means of converting heat energy into the mechanical energy. So this is the most efficient one and also compact one. So due to these advantageous features, that is compactness, compact power packed machine system, in which all the processes that are needed for conversion, that means from heat energy to the desired mechanical energy, is taking place inside the engine cylinder. That's why it's called as internal combustion engines that we know. And these engines are being used universally. So nowadays, so for everything, that means our day-to-day life, whatever we require. So that means the major part is the transportation for the various sectors. Okay, so almost all the transportation, automobiles, locomotives, aircrafts, they are using such the engines. So here the major factor is, that means for the improvements, that means day to day in the our life, since we require the mechanical energy for various these cases, so we have to think about its performance. Otherwise, what happens? Of course, the mechanical energy we are getting out of the consumption of the fuel, it's a petroleum product. So with the decades, so as we know, the fast increase in the population, the industrialization, so that is demanding more and more fuel. And this fuel we are getting from the earth crust, that is the petroleum products. And these are going to depleted, so day by day, and in the future, in few decades, we are having a lack of these petroleum products. So it is very essential for us to think about the fuels, that means economical use of the fuels, so that in future also we can run these engines and we can satisfy our goals of the transportation or for the other works. The engines are being used for the various purposes, like running the, okay, so basic transportation, or the running the various the industries, or running the ships. So like this. Okay, so for this, if at all any modification gives a small improvement in the efficiency, so that will save us a lot of amount of the fuel. Okay, so which will be a advantageous one. Otherwise, the huge amount of the import of the petroleum products, that will be a burden for us, that is a developing country. So that will make the economy down, financial economy down. So for this purpose, we need to think on the advancement of the engines. So here we'll just have a look at the slide, wherein it shows the demand of the fuel. It is a major demand. That means more than 80% fuel is required for the road transportations, and other they contribute very less. That is the non-road the transportations. The road transportation, that means mainly the vehicles, automotive vehicles. So that not only consume these fuels, but also there is a major serious problem is with the emission. They emit a very harmful the gases like carbon monoxide, carbon dioxide, or the unburnt hydrocarbons, oxides of sulfur, oxides of nitrogen, which are very harmful for the human beings. Not only human, but also environment. So these emittents are to be reduced. So these are the two major problems before us as an engineer or as a scientist. So one, to improve the efficiency of the IC engines so that the more and more power can be obtained from the fuel. Other one is the emissions that are obtained or that taking place due to the automobiles that are to be reduced. So these two major problems can be overcome only by the invention of modern and a very advanced using the advanced technology in the engines. Most of the companies already they have adopted. So still there is a scope for improvement in the design for the engines, IC engines. So that is why the design, the improvement is going on day by day. So every company, they have every manufacturer, they have the R&D, research and developments departments, and they are working day and night so that newer and newer engines they are bringing up, and thereby we are getting what the new cars you find on the roads. They are fitted with the most advanced engines, either petrol or diesel. Okay, so with the improvements, so year wise, so this year whatever they are, so next year you will not find these engines again. The most improvements you will be finding out. So in this session we'll be discussing what are the improvements that are taking place and what are the recent advances that are being considered for the design of the engine, such engines. So before that, okay, so here let us have the glance over the engines. Okay, so basics of engines. It's actually not necessary, but part of that one. So those who are not have studied this, so for them it will be useful. So for that, I'll go quickly over the engines fundamentals. So internal combustion engines is the compact engines, and that machine is invented in the early 1980s, 1680s, and it is first invented by Christian Huygens, the German scientist. This engine is mainly used, that means it converts the heat energy into the mechanical output power. Basically, this engine utilizes the slider crank mechanism, that is, which consists of slide, that is a cylinder and piston arrangement connected to the connecting rod and crank, and thereby reciprocating motion is converted to the rotary motion. Simple mechanism. And this, in order to move the piston, so some gases are to be expanded, and thereby that gas, that is the air, is taken and it is heated by means of burning the fuel. And so that's why all these processes are being carried out inside the cylinder. Now, as you know, there are various types of the IC engines that are classified, so based upon the various categories. So mainly we have the two types, two classifications, major, and others are the sub classifications based on the combustion that is taking place. So spark ignition engine, so that we get. So spark ignition engine, that means the petrol engine. And this engine, as you know, it's a very compact engine, and we're giving the high power density with a low combustion, noise, low vibrations, etc. So many more advantages are there with this SI engines, as you know. And other category, that is other class, is the compression ignition. You can see at part load operations. Okay, so that's the best engines, and the lower emissions of CO2 and CO, carbon monoxide, and unburned hydrocarbon. So this engine is mostly used in for almost all the vehicles nowadays. Okay, because of the economy in the fuel. Then based on the number of strokes, okay, so 2 strokes, 4 strokes, and nowadays the 6-stroke engines are being developed. So for the better efficiency. So regarding the working of this, okay, so as you know, here I have taken the four-stroke engine, that means the petrol and the diesel engine. So just we shall have the fast glance over this, so that the whatever the modifications are needed, so that the performance can be improved and then the emissions can be reduced. So in that way we can think of the four-stroke petrol engine. Okay, so during the suction stroke, the air and fuel are mixed thoroughly, and then it is a sucked during the suction stroke, during which the inlet valve opens, and this continues until the piston reaches to the BDC. And then during the next half revolutions of the crank, that is the piston moves from BDC to TDC, thereby compressing the air fuel mixture into the small combustion chamber or the clearance volume. And then at the end of compression, spark is given, and thereby the more amount of heat is added, and thereby the pressure and temperature of the mixture rises, and thereby it exerts the necessary force and the piston is pushed down. That was the engine produces the power. So hence we call this as a power stroke. And then afterwards, in the next successive half revolutions of the crank, during which the piston moves from BDC to TDC, the exhaust burnt gases will be let out by opening the exhaust valve. So here the valves operations are very important. When the valve gets open, when they close, so that's very important here. So we'll be considering this point, and also the spark. So at the end of compression stroke, we are giving the spark here, right? And due to the spark, the flame propagates, and thereby the heat is generated, and thereby the power stroke is obtained. Now here the timing is very important. When the spark is given, either it is given before the piston reaches to the TDC, or it is given at the TDC exactly. The performance of the engine depends on this. Okay, so we'll be discussing these things. Okay, so in the subsequent topics. And then regarding the four-stroke cycle engine, diesel engines. So here the difference is only during the suction stroke when pure air is sucked in, and then during the compression stroke it is compressed in a small volume, that is the clearance volume, and the ratio is very high. So therefore the pressure will be very high. The pressure, as the volume is reduced, the pressure and temperature is so high that it is enough to self-ignite the fuel. Okay, so that is why it's called as a self-ignition. That means due to the combustion, whatever temperature is generated, due to that one, the combustion ignition, the compression ignition engines. And then the next, during the exhaust stroke, the exhaust gases are let out. So here also the valve operations are playing a very important role in the performance. If they are opened and closed at the right time and at the accurate positioning, so then the intake will be proper. If the intake is proper, power produced will be higher. And if the exhaust gases are removed perfectly, which is done by the exhaust valves, so that means that timing is also very important. And here, Mr. Osparkle, we find at the end of compression stroke, the diesel is injected. Okay, so injector, that means injector timing is very important. So these are the things that we have to consider while modifying or while improvement of the performance of the engines. Now these are the for the advancement of the engine. So that means the combustion point of view we have to look after, that is advanced combustion engines. So the goals and strategies are set up. The internal combustion engines have been used for more than a century. As I told you, it's invented in 1680, around the 1680. Since then, it is being modified, and then significant improvements in the energy we found, and then efficiency is being boosted, and also the emissions are being decreased. Okay, and these things, though it is optimized, but still there is a scope to increase the efficiency and reduce the emissions. So, and the boosting of efficiency or the increase of performance is one of the most promising and cost-effective approach. Okay, so due to this, we can find the fuel economy, and thereby we can save a lot of the fuel. Okay, and thus we can get the higher efficiency. United States already have adopted the most modern engines they are designing, so thereby they are saving 20 to 40% of the fuels through commercialization of advanced engines. So that resulted into the economic, environmental, and energy securities. Using these engines, also, that means there is another scope, they adopted the hybrid engines, hybrid vehicles, which utilizes both the engines, IC engines, and the electric motors. So using this, they were enabled to save the lot of the fuels and getting the more power. The advanced combustion engines, that is research and development sub-programs, has led major advances in engine and vehicle development. And the efficient combustion strategy and emission reductions, health effects, and computer modeling and exhaust heat recoveries. So in this, okay. So out of this, okay, so let us discuss one by one. So how the modifications are being taken up slowly, and thereby you will come to know, okay, so what are the changes that have been taking place from the conventional engines to the most modern type of the engines. What are the new technologies that are being used here? Out of that, one is that is the most recent advances research going on is the homogeneous charge compression ignition engines, HCCI it is called. So it's nothing but SCCI is okay. So we have the petrol engine. So there the advantage is the fuel is mixed before entering into the cylinder in the carburetor. Okay, so air and fuel are mixed properly in the correct mixture, correct proportion. Okay, and then the fresh charge, that charge is inducted into the cylinder. So this will give us a homogeneous mixing, thorough mixing of the petrol with the air in the correct proportion. That's the advantage of the spark ignition engine or petrol engine. And in the diesel engine, what happens during the suction stroke? Only air being inducted, and then at the end of compression stroke, the diesel is injected. So this will not give the proper mixing thoroughly, because the time that is available for that combustion is very, very less. And due to that one, some part of that mixture will become a heterogeneous, not homogeneous. If the mixture is not mixed or homogeneous, so the combustion will not be proper, uniform. The heat release rate during the combustion, so that will not be uniform. That leads to abnormal combustions. So this will give the abnormal peak pressure rise or the torque output, all these things. So that means adverse effects it gives out. Now we mix up these two. That means the advantage of the spark ignition engine, that means the mixing, thorough mixing of the fuel, and then the high, that means the combustion in the diesel engine case. So if we mix up the advantages of both the SI and CI engines, so that will give us a very proper engine. It's called as HCCI, the homogeneous charge compression ignition engines. So here in this figure you can observe. So the advantage of this means mixing and this homogeneous charge, so that is giving out this. So here what happens, this is here we are getting a very lean charge, lean mixture, this one. So it works on the lean mixture conditions, and thereby, and also the spontaneous ignition combustion occurs in this case, HCCI. Okay. So due to this, the heat release will be taking place, and due to that one, the peak pressure rises at once, and this gives out a lower output, and also the lean burning, that means the power produced will be less because the amount of heat generated will be less. So thus it is giving the disadvantages, the low power range and the lean mixing. So that is giving the peak pressure rise. That means the range of the torque that is generated, so that is be very less. So this produces inherently low emission. That is the added advantages, because the temperature of combustion is very low because of lean mixture. So due to the low temperature, what happens? The oxides of nitrogen will be less. That means NOx, which is a very harmful gas. So that will be reduced here in this case. The other part, other component, so that means the carbon monoxide part, so that also will be reduced. So in all, in general, the HCCI engines, so it is giving a less harmful emittents or almost less exhaust gases. Okay. So, but only thing, the only so power produced that hampers. Already this engine is being tested by the General Motors in 2007. The concept is being used, but still some modifications are going on. The latest, that means technology is being used to improve the performance of these engines. Due to this one, it is found that the 15% of fuel economy can be obtained. It is obtained. So it is tested with the same size engines, with the diesel engine and the HCCI engine. So it is giving a 15% more the fuel economy. These are the advantages. That is what we are discussing. That means it's a fuel is a lean fuel burning. So they can operate at diesel-like compression. So diesel-like compression, that means the compression ratio for the diesel engine, it is very high, right? So why? That means what is the advantage of high compression ratio? So with the compression ratio, the efficiency will go on increasing. That you have seen it. So as the compression ratio increases, the efficiency, thermal efficiency also increases. So in case of petrol engine, we cannot go beyond certain limit because of the knock problems. So here in this SCCI engines, we can have the compression ratio greater than 15 and thus achieving 30% higher efficiency than the conventional SI engines. The mixing of fuel and air leads to cleaner combustion here in this case and lower emission. So due to low temperature, as I just highlighted that one, because of the peak temperatures that are significantly lower than a typical SI engines, NOx production will be less. It is a negligible. So that is a very added advantage nowadays because for the diesel engine, so we are just getting the NOx, that is a very harmful gas. Okay, so that can be controlled here. So in SCCI engines, so they can operate in multi-fuel, that means either gasoline, that is a petrol, or diesel we can use, or the alternate fuels, even biodiesel can be used in that HCCI engines. So it avoids this engine, that means since here the throttle is completely absent, so therefore throttle losses are avoided, and this will improve the efficiency further. The major disadvantage with this, the HCCI, is the cold starting because of lean mixture. Okay, so starting problem will be there, of course. Okay, so that needs again the heating plug and all those things. So extra attachments are to be provided. Then heat release and pressure rise rates contribute to engine wear because of the peak pressure rise. So after burning, so that means during the combustion, so fuel is getting burned spontaneously because of homogeneity. So therefore that rises the peak pressure at once, and thereby that due to high pressure rise, the wear and tear will be more. Okay, so this is one disadvantage of this. Then auto ignition is difficult to control. That means in case of petrol engine, we can control the timing of the spark that is given. So with that, we can make the burning, okay, according to that, means we can optimize the efficiency or performance of the engine. And in case of diesel engine, optimizing the timing of the diesel injection, so that will change the performance. So we can optimize these things. But here in the HCCI engine, so that is very difficult. So here we are getting the small power range. Power production will be within a small range from no load to full load. And lean flammability limits, that means power. Then high loads by in-cylinder pressure restrictions. Then carbon monoxide and hydrocarbon, so that are the higher than the typical spark engines. Carbon monoxide hydrocarbons are pre-catalyst emissions are higher than this and are caused by incomplete oxidations. And since NOx is absent, so therefore no need to take care of this. So even these components, the CO and HC, so they can be controlled by burning, and therefore the catalyst that is required, so that can be avoided. And here you can show the comparative the study. That means I have shown the graph of this, comparing the conventional engine and the HCCI engine, the spark igniter. So you can see the thermal efficiency is being raised, about 10 to 15% increase in the thermal efficiency we find. And then for the emission wise, carbon dioxide, so here it is very less for the SC, which is an advantage for us. So this is SCI. So still research is going on. So much of the research is going on, and in future we can get the SCCI engines. So here this is a slide that shows the combustion temperature and pressure. So what are the limits? Just for your information, just I put this slide. The combustion, that means Otto cycle, that is a petrol engine, the diesel engine. So here in the normal cases it is 60 bar and 100 bar in the case of diesel engine. And so like this, so these are the values. So you can find the temperatures. In case of auto engine, petrol engine, it is maximum temperature 2200 degrees centigrade, and in case of diesel engine, 2000. So if the turbo engines are used, that means boosting is done. So then it rises to 2500 and 2200. So just these temperatures, so they are playing a very important role in case of the output power and also the emissions. Okay, so now after this, let us come to the major areas where the advancements are possible. Okay, so the things on which we concentrate so that the performance can be improved. The vision behind evolving the IC engines was to extract maximum power, okay, of course, with a minimum fuel consumptions. So, okay, with this optimum performance we can get, and also the reduction in the emission from the engine, so we obtain it. So there's a major contribution. So that is what we require nowadays in order to satisfy the norms that is put forth by the emission authorities. The major areas of advancements are the engine design, then material selection, timing control. Just now I just highlighted what timing control, that means the wall timing control or the fuel injection timing control, all these things that are there. Then fuel injection and the combustion, so that is being controlled. If it is controlled, so we can have the variation in the performance. Then utilization of some alternative fuels. Okay, so as the depletion rate of the petroleum products are increasing at the faster rate, so we have to have the alternate source. So therefore, the biofuels are being are in research, invented. Okay, so the research is being going on these biofuels. Okay, so we are not discussing about the biofuels. Okay, now at present. Okay, so these are the things that means that are to be that we are going to discuss. Then the early designs involves a single cylinder. So whatever that means early vehicles, they were fitted with a single cylinder. So if the more power is required, larger diameters they were using, and thereby the stroke length also. So in that case, the engine becomes a bulky. So with a single cylinder, a lot of the problems that are arised that causes the large amount of fluctuations. That means dynamic point of view and also the power output point of view. The consumption is very high. So therefore, these are the restrictions that they were there. So using the more number of cylinders that have been considered for the more power, okay, and the reduced fluctuations. So dynamically the engine was balanced due to the addition of the engine cylinders, and also the engine has been made compact. Instead of using single large cylinders, so we can use a smaller diameter cylinder, multi-cylinders. Okay, so this solves the dynamics of the machine, of the engines. Now the engine structures, how the engines are placed. So based upon that, on the engines, we find the many types of engines. In that, the inline engines, what you find, that means 3-cylinder, 4-cylinder, 6-cylinder inline engines, which are used in the cars, buses, and trucks. All are inline engines. Then V-type engines. Okay, so then flat type, that is a horizontal cylinder or a opposite cylinder type. Then radial engines. So these are the engines based upon the classification, based upon the positioning of the cylinders. So these are the sketches. That means a V-type engine, this where the cylinder access lines are along the V line. Okay, and then the major, okay, so we'll just discuss the advantage and disadvantage. The number of cylinders can be arranged, so 6 to 12 like that, and the engine can be made compact. The length of the cylinder will be very less, crankshaft will be very less, right, and more power can be obtained with this. The opposite or the flat type or horizontal engine, what we call this one on this side. So this is okay, so from the balancing point of view, it is very perfect. Cycle pedaling, so just like that, opposed to crank. So balancing is not a problem here in this case. So one thing is solved. And also the torque fluctuation is being reduced much more by this positioning. Okay, so in this, and then the inline engine where the cylinders are placed in line parallel to each other. Okay, so this is it is having a much more advantages. I'll discuss that one. Then the radial engines. So the cylinder lines are placed along the radial lines, which all the connecting rods are connected to the common crankshaft. Okay, so this is the advantage. So let us see the advantages, comparative advantages quickly. So V engines, okay, so more piston, that is 6 to 12 cylinders are being used in the V engines. The crankshaft length is a very shorter one, and it has a small crank. Okay, so that is a more advantage. So within a compact space it can be fitted. More torque output we get, so due to the more number of cylinders. Then good power to weight ratio, high power, and the high power is there, so weight will be less. Then high speed, more power strokes. Okay, then disadvantages of this V cylinder, so when you just discuss, so that means we have the more components that are involved. It is heavier, more expensive, and more complex in design. The horizontal, okay, so other engine, the horizontal or the boxer type engines, where we find the perfect balance. Again, dynamic point of view, it's very, this one, very balanced engines. And the power boosting is the added boost. Then unique design, okay, opposed cylinder, unique design. So this means the engine is height wise it is very less, because all the cylinders are placed in a horizontal plane. So that will make the height of the engine less. Due to that one, the center of gravity will be reduced. So this engine will be more useful wherever the center of gravity of the vehicle is required to be very less. For example, the racing cars. So there, the horizontal cylinders are engines are preferred, and it's also more powerful. The only thing is the size becomes larger. Horizontal way it is expanded, so therefore the size is more, and the bit complex. And maintenance wise also it is giving the more maintenance problems. Then radial engines, okay, so much simpler design, and it is reliable and easier to build. Okay, so thus from the service point of view, it is very easy, comparable to inline piston engines. Even the cooling of, that means the cylinder can be cooled evenly throughout. That means radial engine, so all along that. Very short space, front to back. Okay, so again, just like a V engine. Then a light, that means it's a very lighter. That means light engine can give the higher horsepower. Within a compact the space, the high power can be attained. So only thing is, here in this case, it is the lot of oil, it consumes lot of oil is burned. That is a one disadvantage. Then significant drag from the huge surface area presented on this airstream. Okay, so since the firing are in the radial lines, and they tend to leakage problem will be there in it. So these are the relative advantage and disadvantage of positioning of the cylinders. But we are mainly using in almost all the vehicles inline cylinder engines. Okay, so the major advantage is naturally balanced. They don't normally need a balancing shafts. Okay, the forces that are produced by the various pistons connector that is transmitted to the crankshaft will be uniformly distributed. So due to that one, it produces less vibration, less noise, and less wear and tear. So thus the bearings are loaded less. Then it gives us smoother operations. and have higher top end as a piston. That means all the pistons are firing in the same directions. Okay, so smooth operations, smooth combustions, so that are the added advantage of this inline engines. Disadvantage, the only thing is it is a taller one. Okay, since the cylinders are placed parallel to each other, the length of this, that is the stroke or the cylinder, the cylinder becomes a taller one. So which if it is fitted to this vehicle, there will be aerodynamic problem. Okay, so that is a major disadvantage. And then the inline, the engine tends to be heavier. They need a stiff blocks and lots of support to support it in order to avoid the vibratory motions. Okay, so this is around the positioning of the cylinders. Another parameters for the advancement is the material selection. Material selection is very important, as you know. So because the engine is working under various conditions, operating conditions, like some some elements some elements are working at higher temperature, some elements are working at higher fatigues, and some elements are working under vibratory natures, vibratory forces. Okay, so we have to take care of all these while designing it. So weight of the material, that means lightness is very important, uh, and so that it can operate for the high temperature. Okay, so there the care to be taken. Then coefficient of expansion. Okay, so that it should not be deformed under any conditions. Then heat transmission power, transmitting the power. Then vibration and sound damping. Okay, so these are the things that is to be taken care. For example, the piston, high temperature is required, then the high amount of heat is to be dissipated quickly. So the thermal conductivity, we have to see it. Okay, and then lightness is important there. So weight of the material, that is very important in that case. So like this, the material selection. So all these modern engines, they are using the proper smart materials for these engines. That is why they are giving the highest or maximum efficiency, thermal efficiencies. The main materials or the metals used in the engine manufacture by the engines, that means different manufacturers, they use the different the materials, that is the composite materials or this. That is mainly they consist of gray cast iron, aluminum, and magnesium. Apart from this, the sodium is also used in the engines. The pockets or the engine parts are made hollow. That means the pockets are made, and in that the sodium is filled. Metal sodium is filled, especially where the high amount of the heat is generated or it is subjected to high temperature. There, the high dissipation rate is required. For example, the exhaust valve, which is operating at a high temperature. The high temperature gases are flowing over the wall when the wall gets open. So their high dissipation rate is required in order to operate coolly. So for this, the wall is made hollow, and in that inside the sodium is filled. When the temperature of that part becomes or the greater than 160 degrees centigrade, the sodium gets melted. So melting point of that one is 160 degrees centigrade. So whenever it crosses, the sodium melts, and the in the molten state, the thermal conductivity of the molten sodium will be very high, and thus it dissipates the heat very quickly. So the application wise, so sodium valve, that is the exhaust valve, and the piston skirts. Okay. Then the next parameter that we'll discuss for the improvement or the advancement is the timing control. The efficiency of the engine is depends mainly upon the timing of its sequence operations. The timing of inlet and exhaust valve, when they are opening and when they are closing, exact timing is required, because the inflow, though, that will have the impact over the power produced. Then the outflow of the burnt gas, that is the exhaust, that will have the adverse effect on the engine. So if the scavenging is not proper, it will lead to a dilution of the fresh charge. So the timing must be correct. The timing of the spark that is given in case of SI engines. Then sequence operations of each cylinders in multi-cylinder engine. That means when which cylinder is firing. That is a sequential operations, firing order, what we call. So these are the things that are there to be considered. In normal case, these timings are design parameters set at the time of manufacture. They are fixed. For the conventional engines, they are fixed. Whatever the engines, that is the industrial engines are there, so they are fixed. They cannot be changed. Now the modern vehicles which are there, so in that case, these timings can be varied during the operations. That is a very advancement is taking place. All the vehicles that you can find it. So there the timing is varied according to the conditions of operation, that is the low speed, high speed. Okay, so during the power boosting, so like this. The goals of timing control is to change the time of engine while it's working. So in order to boost the engines. So timing of inlet and exhaust valve, that is here I have shown the figure. That means you know the water thermodynamics, you have studied it. So in this case, you can see the inlet valve, that means actually it should open, theoretically it should open when the piston is at TDC, but it is opening before the piston reaches to this. So that means this extra, that means 20-25 degrees is provided in order to suck the more amount of fuel. Okay, so that by the time when the piston reaches to TDC, the valve will be in fully open condition, so that it gives the maximum passage for the inflow of the air or the fresh charge. So that's what it's given. And thus, again, you can find here the exhaust valve. The only important point I'm just highlighting. Exhaust valve, it's opening before. That means actually theoretically it should open when the piston is PDC, but it is opening before that. Okay, around 40 to 45 degree before the BDC. So the purpose is the burnt gases already they have expanded, and most of the gases have been expanded, and it has given the work, and now it is ready to be expelled out of the cylinders. And therefore, if it is open, the high pressure will let out the gas out of the cylinders. Okay, so this will help in evacuating the cylinder. Okay, the proper scavenging will occur, so that by the time when the piston reaches there, so at the TDC, the complete cylinder will be evacuated, and it is fresh and it is ready to suck the fresh charge. So similarly here in this case, for the petrol engine, so you can find this. Okay, so this you have studied also. Okay, so just I think no need to explain here this one. Okay. Then the sequence of operation of each cylinder in the multi-cylinder engine, so that that is the one of the part. So here the firing order, that means the order in which the firing is taking place. All the cylinders will not fire at a time. Okay, so one by one. So if the suction is going in the first cylinder, then the other cylinder will be in compression mode, other cylinder will be exhaust mode, and like this. Okay, so next the cylinder number 2 will fire, or next in the next stroke the cylinder number 4 may fire, or third. So like this, the firing order is based, that is decided based upon the balancing point of view. The manufacturer, it depends on the manufacturer. So from manufacturer to manufacturer, it changes. So there's the one thing. So we just take care of this. Then the sparking of the spark plug in the gasoline engine in the correct order by the sequence of fuel injector in the diesel engine. Okay, so these are the things that we just take it. That means firing. That means firing is done by just giving the spark by the spark plug in a SI engine, and by injecting the fuel by the fuel injector. So these timings can be altered. When designing an engine, so appropriate firing order is to be selected. It is a critical. That means if it is not properly maintained, that means it leads to vibration. So that means it should be such that order is critical to minimize the vibration and achieve the smoother running conditions. For this, for the longer engines, fatigue life and user comfort and heavily influences crankshaft design. Okay, so that all depends upon this. Okay, so for the conventional engines, all these timings are fixed, but the modern engines, that is with the advances for the purpose of improvement in the power, these timings are varied. They are called as a variable wall timings. All the vehicles which you find on the roads nowadays, so they are fitted with the most advanced engines with these features. At the low RPM, the timing is adjusted for maximum efficiency. Why? That means at the low RPM, the fuel consumption will be less. So therefore, the thermal efficiency will be high. So therefore, the RPM it should be set like this. And at high RPM, the wall remains open. Okay, for boosting the more amount of fuel, that means the opening size should be increased. So these are the factors we require. So then only the RPM we can get it. This helps to pump more charge to cylinder without creating back pressure or the scavenging. That means scavenging is the process by which the gases are driven out without having the back pressure. So for controlling these wall timings, okay, so at what time, what should be the duration, at low RPM, at high RPM, at high power range, at high torque. So these are the various operating conditions that we get while operating the vehicles. So all these timings are controlled by a microcontroller. Okay, so which will control the solenoid and with which the wall can be opened wide or opened less. So like this, it can be controlled by a microcontroller. So in the mechanical system, it is coupled to a gear which is locked to the cam using the pin that you know. So these most computer controlled engines, they are varied like this. So they are called as VVT. When adjustment is needed, so that means in case of mechanical components, a pin is removed magnetically and the stepper motor adjusts the cam. So these are mechanical means. Okay. Almost all the manufacturers use this technology in their advanced engines or the powerful engines. There are more or less a norm to use these. Okay, so there is no definite a rule for that. Okay, so they use different manufacturers, they use the different norms. So it would be impossible to meet the strict emission norms that are in place without this. Okay, so according to the norms, okay, so if you control these watt timings, okay, so it will boost the power and also at the same time the emissions that are taking place, so that can be controlled. Okay, so for this timing is very important. So likewise, the modern vehicles, you can see some they are written. Okay, so if you have a vehicle, that means Hyundai vehicle, so their VT it is written, variable timing wall train, or the Maruti Suzuki VVT it is written. Okay, so that means the wall variable timing. So timing is changed according to the performance. Continuously it changes. So microcontroller changes and it is varied, and thereby it also continuously will have the power fluctuation, that means observations. So then VVTI, that means intelligent variable wall timing and a lift with electronic control system that we find out. So different manufacturers will have the different this one. So but the main theme is to change the wall. So these are that I have listed. IVTech, that is Honda is adopting. Then TI VCT, that means a pin independent variable camshaft timing, that is Ford is adopting that one. Then Fiat is adopting VIS system, that means Fiat pin cams. Then BMW Venos system, again it's a VVT only. So General Motors, again it's a VVT. It's a most technology. So that's why on the car it is written VVT or VVTI or IVTech. So you have observed that. So here how it happens. Okay, under the no load conditions or whenever the power requirement is very less or the engine is operating at a low speed, the wall lift is very less. Okay, so this is lifted to a small distance or small lift. In the cruising mode, that means high speed operations, the wall is lifted wide height so that more and more amount of the charge can be sucked in or inducted into the cylinders. So this is the technology. This is a wall mechanism wherein we find out in the IVTech, that is intelligent variable timing and lift, electronic controlled. So this is a system. So this IVTech, it is a combination of VTech and VTC. Okay, both intelligently it operates for both the condition. So this is how the walls can be operated, and this is a mechanism where the wall camshaft can be adjusted by means of the solenoid walls. It can be shifted up. Okay, so corresponding shifting is taking place. So therefore the lobes that is touching the cam, so that sometimes it makes without the lobes, that means it is inoperative. When it is shifted to this one, so then it comes in contact with this lobe and it is pushed through a higher displacement. And when it comes in contact with this, so it is pushed through a smaller displacement. So thus it can vary the wall displacements in this case. So thus we can have this technology. So almost all the manufacturers are adopting this for the enhancing the performance. Then another the parameter we have is the active wall train. Active wall train, here the two cams that are used for the two different conditions, road conditions. So when the microprocessor detects that the vehicle is moving on the rough terrain, the cam used will be one for the more power. More power will be generated. That means it is the cam is adjusted so adjusted that the more displacement it gives. Okay, so in that way it is moved, and thus the power can be boosted. And during the cruising, the power requirement is very less. Okay, and thereby the that much of displacement is not required. So therefore, automatically the microcontroller switch off or switch the cam to another lobe, which is having the less depth, and therefore the operation is being adjusted for the high efficiency. Okay, and then the this is introduced first by the Lotus Motors and later developed by the Nissan Motors. So they have adopted this type of this. So this here you can observe this how the mechanism is being placed. So a smaller lobes and the higher lobes, one cam profile, the other cam profile. Okay, so rock around. So this is how it is operating. Okay. And then the cylinder deactivation. See, sometimes we do not require the much power when the vehicle is running under a steady speed condition or cruising mode. So that much power requirement is not required. So it is if we deactivate some of the cylinder, that means that if we stop the firing in some of the cylinders, so that the fuel saving can be done. So this is how the technology is being developed. Cylinder deactivating the cylinder. Cylinder deactivation is derived form of active cam switching. In this method, while cruising, a part of cylinders are switched off by switching to a cam without the loops, just cylindrical, okay, circular loops, without having any risers. This method is successful because it will lead to a lesser fuel consumption, less heat generation, and lesser power lost in managing other cylinders. Okay, honestly, so burning of the fuel in the other cylinders so can be avoided. So thus we can achieve the fuel economy. This is mostly employed in V-type engines. The cylinder is deactivated by keeping the inlet valve closed so that there is no fuel flow. Keeping the exhaust valve open so that there is no work done in compression. So deactivation is done. So this is how you can observe here. This is a valve which is mechanically operated by means of the hydraulic power. So when it is in contact or activated, the valve is in action. So that means when the lobe comes in contact with this, so therefore the valve is pushed downwards, it opens. When the locking pin is pushed backwards by the oil pressure, so there is no contact here. So therefore, if this becomes inactive, lobe becomes inactive, and therefore, whenever the cam goes, there will not be any So this is adopted by General Motors in their that means in their models, some of the models, and then Honda is also that is adopting this technology. Then fuel line fuel injections that we find the fuel input, so that highly influences the emission from the engine. Okay, when and what quantity of fuel to be injected, so that adversely affect the performance. And also not only that, the mixture, air fuel mixture, okay, which is called as a charge, that is introduced to the cylinder, that is when before the compressions. And in CI engines, fuel is injected after the compression stroke, at the end of the compression stroke of the cylinder. This helps in attaining the higher compression ratio. Because of this, higher the compression ratio, higher the performance. That's there. So in SI engines, it is not possible, because there is a chance that the fuel may burn beforehand. Because if you increase the the compression ratio, so there is a possibility of knock. And thus the compression ratio is limited by the knock in case of petrol engine. So therefore we cannot increase beyond certain limit. And therefore since the thermal efficiency is a function of the compression ratio, therefore thermal efficiency will be less for that. We cannot go beyond that. Okay, so DI engines, that means a direct injection in SI. Right. So far the SI engines, they were using the carburetors, where the fuel and air are mixed thoroughly by the carburetor and that was injected. But now that technology is absolute. So it is being converted. The SI engines are modified to work just like a diesel engine. So with the direct injection, as we get the advantage of CI engines. Okay, so in the direct injection, first the air is filled as same as that of DI engines or diesel engines. Then halfway the compression stroke, a small amount of fuel is injected into a cylinder, so that the mixture is formed, a lean mixture is formed. And as soon as the piston reaches, that means at the end of the compression, just before the spark, the rest of the fuel is injected. Okay, so which leads the combustion. So thus the burning will be stratified. That means the burning of the fuel occurs in a stratified way. So it is more uniform. Then the direct injection has many advantages, such as no need of carburetor, easy design of manifold, better compression is achievable, no case of knocking in engines, lower NOx emissions. Due to stratified combustion, leaner mixture can be used. So this is our engine, how it is done. So it's a petrol engine actually. So therefore, this is how the injection is being made, like this. Okay, by controlling the microcontroller, using the microcontroller, the wall opening and closing is done. That means a common rail injection, so CRDI engines. So it's a diesel engines. So here 4-stroke cycle with a gasoline, that means a direct injection engine. So this is how it is taking place. So it is a multi-point fuel injection, MPFI engines. All these nowadays, what petrol engines are there, so they are the MPFI engines, and the diesel engines, that is the CRDI engines common. So where the high pressure is created on the common rail, common tube, and then whenever whatever cylinder is needs, so that valve will be open and then ready charge is given to. So these are some of the modifications, and then over that the superchargers, in order to enhance the power of the engine, existing engine. Suppose the engine, we are having the engine of say 5 kilowatt. So with the same engine we can go up to 6 or 7 kilowatt by boosting extra amount of air. The natural aspiration, whatever the engine is there, so over and above that, if the air is inducted, so then the more power can be achieved. So this is what the principle is. So this one is used. So the extra putting of air is done by means of a supercharger or the turbochargers. So superchargers are the compressors coupled to the engine. So that means it is run by the engine crankshaft itself by means of the belt drive. Okay, so that means as the engine rotates, that means air is sucked in and compressed, and then it is fed to the cylinder. Compressed air is fed. So at a higher pressure, if you just supply it, so more air will be going in. So that's natural. Increasing the amount of oxygen to the engine will give the better burning, and it is a must in aircraft flying at high altitude where air is less. So this will help where the aircraft engine can have the most air to be boosted in. Then another way of the enhancing the power is by using the turbochargers. Working principle is same as that of superchargers. Here, turbochargers are not connected to the crankshaft, but these are driven by means of the exhaust gases that is coming out. And due to that one, the power is generated and that is coupled to the compressor, and due to which the air is compressed and then it is supplied to the engines. Okay, so thus we get this. Okay, so these are the regarding the fuel that we can have. We can improve the performance by these means. So another concept, apart from the two-stroke and four-stroke engines, nowadays that is being taken care or it is being taken for the research is the six-stroke engines. So it has an advantage. That means six-stroke engines. It's a basic engine. So only thing what happens, it's a combination of two-stroke. That means the advantages of two-stroke, advantages of both two-stroke and four-stroke are combined together. So that is mixed. So therefore, it's called as four strokes and two strokes. That means total six strokes. So like this, the engine is being designed in one. So it has a less weight to power ratio, less scavenging. But in case of two-stroke engine, scavenging problem is there. Okay, but in four-stroke engine, that is not there. So therefore, here it can be completely avoided. So the advantage of four-stroke cycle engine is taken care. Less moving parts. That means two-stroke engine is having the less moving parts. So therefore, that advantage is being taken care. More power and fuel economy is obtained because of six strokes. Clean burning is obtained. So clean burning leads to fuel economy. And then complete combustion leads to more power. So the six-stroke engine gives the more power and fuel economy. Then there is a much freedom in designing, and the better cooling can be obtained in case of the six-stroke engines. So in two different ways it can be developed. Okay, so this is how you can observe this a sketch where the six strokes are being shown. So first four, that means it is quite same as that of the four-stroke cycle engine. During the suction stroke, the intake valve gets open and the fresh charge gets in, and then the compression stroke, it compresses, and then the power stroke, the fuel is burned. Okay, so then during the exhaust stroke, exhaust valve opens and the hot gases are let out. But still, the cylinder part, that means the top of the cylinder and the combustion chamber, it is still hot. So that means that heat can be recovered. So after this, so in four-stroke cycle, what happens? Again, the intake stroke starts. But instead of taking the intake, starting the intake stroke, now it is taken. So that means during the next, after the exhaust, some water is being fed to the cylinder. And due to this water, that means since the cylinder piston top, cylinder surfaces, they are hot, and this water will get the latent heat and thereby it is converted into the steam immediately. Due to that, the volume increases. As the volume increases, okay, so the piston will be moved downwards. Okay, due to the increase in pressure, so therefore the piston will be moved downwards. So this is how another power can be obtained. And then afterwards, the steam whatever is generated, that is let out. Okay, just by keeping the another wall, that is a steam wall. Right. So thus here you find three walls, one intake, another one exhaust as usual, and one more the steam. So the events, that is four-stroke events as usual, plus two events, that is the feeding the water to generate the steam and thereby getting the power again, and then exhausting the steam to the condenser, two strokes. So therefore totally six strokes. This concept, that means the design is under again research. That means its research is going on. So these are the things that are there. Okay, so that only I just given this slide here. Then these are the things, that means the companies that are working on this analysis. When the performance analysis is being done for the comparison of the four-stroke cycle engine and the six-stroke cycle engine, you can observe this. Okay, so this is here the perform, that means the efficiency, thermal efficiency of the six-stroke cycle engine is giving much more than this. Okay, so that means about 40 to 50% higher than this. It one. So therefore, the six-stroke cycle engine is also very good concept for the advancement in the IC engine field. Then the last parameters, a compression ratio. Compression ratio is a very important parameter as far as the efficiency, thermal efficiency is concerned. Okay, so all of you being the thermal participants, thermal streams, so you know this. Thermal compression ratio is a function of the thermal efficiency. As the compression ratio increases, thermal efficiency also increases. So this is being used for the advancement of the problem. Okay, so here for the conventional engines, it is being kept constant for all these engines, whatever we are having. So it is constant. It cannot be varied. Now the engines are coming up. The research is going on. So that means as this ratio changes, that means that will enhance the efficiency. Okay. So thus the variation in the compression ratio is being done. It is being tried. So it's called as a variable compression ratio engines. It can be changed. Okay. So based upon the fuel that is being used, we can change it. So multi-fuels also can be used if we have this provision of the variation in the compression ratio. So this is the field of research. Okay, so here the compression ratio cannot be increased to a larger extent in case of the SI engines due to the knock that is being applied. So a continuously variable compression ratio, that's what we call it as a VCR engines, auto cycle, that means SI engines, that is inherent to the operation on full or part load with a high efficiency and same octane ratings. Thus, an engine thermal efficiency can be increased by continuously varying the compression ratios. Due to the higher compression ratio, it is possible to achieve good fuel economy. That is there always. Okay, so these are the things that we just get it. Okay, so SI engines and the CI engines, so where it can be increased to a still larger extent, and with the increase in this, the emissions will be lower, but the inefficient, so like this. So these are the various parameters that I have discussed so far with you. And with this, okay, so we can think that, okay, so combination of all these advantages, we can have the engines, future engines, which will have the advantage, that means what we have, the smooth running, low emissions advantage of the SI engines, then higher load taking capacity at the higher power at the part loads characteristic of the CI engines. So combining this, if we develop this, so that will be an ideal engine for us, and we can use it and we can have a future engine. So we as an engineer, so we require such types of engines. It's a dream of automobile engineers. Okay, so these are regarding the performance parameters that we have discussed it. Changing the hardware of the engines. Okay, by small changes or this one modifying completely the engines, we can get the higher efficiencies and lower emissions. The other side, that means we can have, that is the fuel. That means as the petroleum products are depleting day by day, so we have to have a search for the alternative source of the fuels. So nowadays the biofuels are being used as an alternative source of energies. Biofuels that are derived from the vegetable oils that you know. Okay, so it is a renewable in nature. Abundant quantity of vegetable oils, we can extract it. Okay, so this can be used for the vehicles in future whenever we are lack of the petroleum products. The tests are being, many researchers are being working on this biofuel test sites, and nowadays some of the engines are being tested or are also running at about 20% substitute of the biodiesels with the minor modifications over the diesel engines. Okay, so of course I'm not going to discuss on this further because one of my colleague, Dr. Odi Hebard, is taking up this session in the subsequent session. Maybe day after tomorrow he will be dealing with that session. So here he will be dealing with this biodiesels, okay, in detail. So what are the advantages of this and how it gives the performance similar to that of diesel and what are the modifications needed for this. So on this part he will be discussing in detail. Okay. So this is a session in which I just try to give the announcement or recent trends that are being taken place or that are being considered by the researchers in order to improve the performance. These are the advances in the engines. Okay, so thank you, friends. Okay, this is the end of my this session. And if you have any queries, so you just put it on my this one, message it so that I can answer. Thank you very much. And I also thank the team, that means the BIET team, for giving me an opportunity to deliver the topic, IC engines advances on this, and giving me a chance to have the session in your FDP program. Thank you, sir.
Thank you, sir. Thank you. The session was very informative and it was very useful for us. Hope that we will make use of this and we will make the session very beautiful. Sir, hello. Sir, do my voice audible, sir? Hello. Sir. Sir, please answer the queries which is put it in the chat box, sir. Sir. Sir.
Okay, sir. Is it audible?
Sir. Sir. Sir, if the questions are there in the chat box, please do answer those,
hello?
Sir. Hello. Sir. Sir.
Hello.
Sir. Is my voice audible, sir? Hello, sir.
Hello. Hello.
Sir.
Hello. Is it audible?
Sir. Yeah. Yes, sir. Sir, the thing is, if the questions are there in the chat box, sir, please see the chat box. If the questions are there, please do answer those, sir.
Okay. Okay, sir. Okay.
Yes. Sir, the question is, what are the difficulties in designing 6-stroke engines?
Yeah, 6-stroke engine, actually it is under development, so it's already been tested, that engine. Okay, so only the water particles that are inducted and then cleaning, so that becomes scavenging is the main problem for that. But also, so it is under progress. Okay, so most of the vehicles, that means the engine is being tested, and it is working perfectly. So there is no such problems.
Okay. Sir, there is one more question. Any modification of heads is carried and any advantages that are there for it?
What done? What is that?
Any modifications of heads, wall heads is
Heads.
carried and
Yeah, yeah. Yeah, many advantages are there. Overhead so there are many types of the heads for the IC engines. Okay, so in that, okay, so all overhead wall, overheads, and the L shape. So that depends. All depends upon the depends knob characteristics and all those things. So overhead cylinders and the heads, they are the more powerful. That is why all the engines are developed based upon the overhead only.
okay. Sir, there is one more question, sir. His name is Vadekar, BD Vadekar. Will the
Okay.
electric cars replace those with internal combustion engines?
Yeah, it is a combination of electric cars. So what the Americans are just testing, they are running the cars in parallel with that. So both the IC engine and the electric motors, they are placing it. So whenever they are requiring the boosting, so they are using that means the high torque and high power are required. So they are using the IC engines. In the other case, they are using the electric cars, and sometimes they are charging they are converting the electric power by the IC engine, and then they are running the electric motors. So this type of hybrid type of the mechanism they are doing it. They are using it.
Oh, okay, sir. Okay, sir. Sir, there is one more question, sir. Sir, whether electric vehicles, sorry, there is one more question from Sri Srinivasa Murthy. How
Hmm.
many ways the common Kirloskar engine can be converted into HCCI engine? Sir, quickly, sir. The time is up, sir. Please.
Yeah. No, HCCI is different. That is different technology. Okay, so for conventional engines, we cannot do it. So there, the much more modifications or the manufacturing difficulties are there. So it is to be manufactured differently. The conventional existing engines cannot be done this. Okay, so many more modifications are needed for that.
Okay, sir. Okay, okay. Thank you, sir. Thank you, sir. The session was really
Okay,
very informative.
okay,
Over to you,
thank you,
sir.
thank you.
Go ahead, sir.
Sir, thank you, sir. Navindi, sir. Thank you, sir. Thanks a lot.
Thank you,
Having
thank
accepted
you.
and delivered a very good lecture on IC
Mm,
engines. And
right,
we
thank you, sir.
having a
Uh,
vast experience in IC engines. So you have delivered nice presentation, and slides preparation was good. Very
mm,
voice was very clear. Everything, sir. Thank you, sir. Once again,
thank,
thank you.
thank you.
Thanks a lot,
Thank you,
sir.
Joseph.
I am
Thank you, sir. Thank
yeah,
you.
yeah,
Thank you, team
yeah.
members. Okay.
Right.
Thank you,
Yeah.
sir.
Thank you.
Thank you.
Thank you.
Okay.
Thank you. Thank you.
Hmm?